And the charge will transfer to outer potential surface that we done yesterday.
Yes, sir.
Yes, sir.
Transfer of charge.
Yes, sir.
Done, sir.
All the charge will transfer to each one outer surface only, na?
Yes, sir.
Yes, sir.
We have this weekend syllabus. We have this also, no? One minute.
Certain relation between drift velocity and current.
Just a minute. Capacitors you have done mirror image circuits and all, no?
Yes, sir.
So what you call all conductors are electrically neutral, no? Hello.
Yes.
Then we take a conductor, if we take a electrical wire from some copper wire or anything, what happens? The number of electrons inside and number of protons within the nucleus are balanced. There is no portion of ions. These are in the atomic state and molecular state. So if you take a conductor, what happens? This is a conductor, certain area of cross section, some length. Inside there are so many free, it's a metal, so many free electrons will be there. As a whole, the net charge of the system is how much? 0. Total charge in system is how much? 0. And total charge is 0. It is indicated that no ions are present. But due to the temperature, these electrons will have a random zigzag motion. This is called motion due to what you call heat. Then in that process, what happens? They will have, let us say, one electron is there, moves like this, correlates, modifies the path, again modifies the path, zigzag randomly moves. This what you call continuously undergoes a number of collisions with the walls, with the lattice of the what do you call deciding atoms and electrons and walls of the conductor and all. Then overall, what happens? Even though it has a little bit of what you call thermal energy, it has some energy. Due to collisions, it loses the energy and again sometimes oppose, sometimes push in the forward. So the net motion of the electron, even though it has some speed due to thermal motion, so net displacement will become how much? Zero. That's why even though free electrons are available for the conduction to move from one point, then what happens? It cannot move. Net displacement is zero. There is no propagation of charge. Therefore, what is current rate of dq by dt through a given cross section? How much amount of charge is passing in a given interval of time? It is called electric current. So there is no displacement of charged particles through that any net area of cross section or any cross section. Therefore, current inside a conductor, passenger conductor is zero, even though there is a motion, because the net displacement is how much? Zero. But whenever you apply, one is at high potential, one is at low potential, there is a potential difference is generated, then electric field will be there, then V equal to E, the electric field is there. Therefore, electrons will get an acceleration is equal to force by mass. If electric field is right, electrons will get what you call experience acceleration, negatively charged particles force. Because of this acceleration, these electrons, what you call by default thermal motion, they will have additional push. Then here colliding, losing some energy. But continuously electric field is applied is pumping the acceleration. So what happens? This acceleration provides a necessary, even though zigzag random motion, but what you call there is a net motion from higher potential to lower potential, or electrons will move from lower potential to higher potential. Electron direction is low to high, then conventional current direction is called high to low. So all this happens not because of the random zigzag motion is there, like it collides so many times like this, and but overall what happens? It has a net motion, electrons from low potential to high potential. Then current, conventional current they made, the direction of current is opposite direction of electron motion is nothing but direction of current they made it. So current always flows from higher potential, lower potential. This is possible not in the absence of what you call any potential difference. It must be in the presence of a certain amount of potential difference. That's why we connect to a, what you call any resistor or any bulb, anything, connect a battery. Because of this battery having some potential, it will pump the charge carriers to participate in the conduction phenomena. Got it, Nana? Hello.
Yes.
So what happens in case of insulators? In case of insulators, here small n is number of free electrons. These are the number of electrons per unit volume. This is zero in case of insulators. And in case of conductors, it is a good number. And conductors which are good conductors, so more number of electrons per unit volume is more, means it has a more ability to conduct. Silver is one of the best conductor because silver has highest conductivity. That means free electron density, number of electrons per unit volume are more in silver compared to copper and all. Got it, Nana? Hello.
Yes, sir.
So we came to know that without the help of external what you call potential difference, charged particles cannot move from one place to another place. So in this one, they are forced. They are called what you call the average velocity is zero because net displacement due to which motion? Thermal random motion. But one is at low potential, one is at high potential connected. Electric field is high to low. Then electrons will accelerate in the direction opposite to field. Then this acceleration, V equal to U plus A to take. What is this tau? Tau is called relaxation time. What is the relaxation time? Nothing but the time gap between successive collisions with the electrons or somebody lattice or some atoms or molecules. It is the time taken between two successive collisions called relaxation time, which is called tau. Got it, Nana? Hello. In case of a conductor, generally there are 10 power 28, 26, 30, like that number of free electrons per unit volume. That is called small n is a symbol used for free electron density. Got it, Nana? Hello. Then these electrons are having an acceleration forcibly drifting from one point to another point. So this is a application of external potential difference. That is called forcibly. That's why whatever the speed it acquired, this speed what we call as this is called as drift speed. Got it, Nana? Everybody. Hello. Why use the term drift means forcibly by external potential difference. Got it? Hello.
Yes, sir.
So what is current? Actually rate of change of charge passing through given area of cross section is called current. How the current is responsible in the conductor due to motion of the electron. How the electrons will move on their own? They have zero velocity, average velocity due to what you call thermal motion. Some external potential difference is required. Copy this one, everybody. Done, everybody.
1 minute. What should I put the heading as?
So that is the drift velocity and current, that's it.
And the electron density formula, what is capital N?
Capital N is number of free electrons per unit volume, small n.
Okay.
Done, everyone.
Done, sir.
Done on everybody.
Done, sir.
Yes, sir.
Done.
Copy this side, Lily. This for this much electric field, you acquired this much velocity. This is called drift velocity. Then per 1 unit electric field, how much velocity acquired is called? That is called mobility. Mobility is called drift velocity per unit applied electric field. Got it? Do you want VD by E into tau by? Yeah, you can write like this also. Now we have to derive the formula for what you call drift velocity as. Drift velocity is how much VD by VD is equal to I by NA. You have to derive it. Okay.
Okay.
And then number of electrons are n in a given volume per unit volume small n. Let us take, I am taking some volume here. Area is a length. So total volume of this conductor is area into length. What is actually current? The amount of charge passed through given area of cross section per unit time. Okay. I want what is the charge. Copy this page.
Done, sir.
Wait.
Kannana.
Answer.
dq is the total charge. Each is nothing but electron. If n number of electrons are there, total number of electrons into charge of each electron is E. So total charge is n into E now. Got it, everybody, this one? Logic?
So can you say once again?
Total charge is 1 electron, 1E. 2 electrons are there, 2E. N number of electrons are there. Then what is the total charge? N into E now.
Yes.
Yes, sir.
So how to get N? Number of electrons per unit volume into how many number of electrons in a given volume means N into V, N into A. We expanded that. So I is dq by dt, this much. Got it? What is L by dt is nothing but called as velocity. Why? These are passing from this point to this point. So there will travel the uniform particle. Even though there is a opposition collision electrons is there, continuously are supplying. So on average its velocity. So S is equal to Vt apply. So L is equal to drift velocity into time. Got it, Nana?
Got it.
Now that's why we have taken what we call this L by dt or L by time is called as drift velocity. So I is equal to NEA into. So drift velocity is I by NEA. Got it?
Got it.
Then what is this J? J is called current density, called current per unit area, called as
Current density.
so in terms of J, this is the expression. Simply I by A replaced with J. Got it?
Got it.
Copied, everybody?
Done.
Sir, what is VD, sir?
Ray, order nu drift velocity way.
Okay, sir. What is now?
Emra పడుకున్నావా?
No, sir. Got it. Doubt, sir.
Done this, everybody? Hello.
Done, sir.
Then they'll ask, current is flowing. This is at what you call higher potential. This is lower potential. Potential difference is there. Then electrically higher potential, lower. Then outside of the conductor, electric field is zero. Why? Because it is electrically neutral. We are not bringing any excess amount of charge. Whatever the charge is there, we are making the charge to move inside the conductor. Got it? Hello. Hello.
Yes, sir.
So outside electric field is how much?
0.
Zero. Inside electric field is that. That's why, because that's only electrons are being accelerated. Okay. Hello.
Yes.
Then I by NEA, current is flowing through a conductor. So how much amount of charge? Suppose 10 coulombs of charge is flowing. Then the same 10 coulombs of charge, there is no other path for the charge. So only one path. Then through this cross section 10 coulombs per second. Here also 10 coulombs per second. Here also 10 coulombs. Here also. That means through a given conductor, current is flowing. I remains constant for a given material N, and electronic charge are constant. Then the drift velocity depends on area of cross section. More is the area of cross section, less is the drift. That's why if you take a uniform, this is also area A, this is also area A. Here also drift velocity Vd, here also drift velocity, same value. Here 10, let us assume 10 units. Here also 10. But if you take a conductor like this area of cross section, area is large, drift velocity is small. Area is small, drift velocity is large. But however, only one conductor, there is only one path for the charge. So same charge has to flow through this conductor per unit time. So I1, I2s are equal. and area 1 is larger than area 2. So drift speed here, the speed of the electrons is small. Here, the speed of the electrons is large. Got it? Hello.
Yes.
Yes, sir.
Got it, Nana, everybody?
Yes, sir.
Copy this. Done, everybody? All these three done?
1 minute.
Done. Hello.
Done, sir.
Done, sir.
So, if the conductor is the same area of cross section, then what happens? Current is anyway same. A1, A2s are equal. Therefore, drift velocities are not like this case. This case is different case. Got it? Hello.
Got it.
You have Ohm's law?
No, sir.
Copy this also will do. Finish it. Ohm's law. What is Ohm's law? You are applying some potential difference across a conductor. Current is flowing. So at constant, this is very, very important. Temperature changes. This value will change. Let's see how. Let us discuss. At constant temperature, more is the potential difference, more is the current. So V is so I will be large if more potential difference is applied. So I is proportional to V, some constant. That constant is called 1 by R. Now simply you can V equal to IR, and R is equal to V by I. R is only ratio of the potential difference and I, does not depend on either V and I. R is a constant at a given temperature. It depends on nature of the conductor. Don't think that, sir, as you told, V is proportional, V equal to IR, then we say R equal to VI by. If V is increased, I also will increase. The ratio remains constant at this temperature. Okay. Therefore, V by I, V decreases, I also decrease. So these are dependent. R is not dependent on the potential difference nor on the current conducting. It depends on the dimensions of the material and the nature of the material and temperature. So three factors. R depends on temperature,
Then
nature of the material, and the physical dimensions of the. These three factors does not depend on V and I. It is only relation, empirical relation, just formula type. What is V, what is I? So V by ratio is called R. That's it. But never depends on either V and I. Got it?
yes, sir.
Copy Nana this one.
What density, sir?
Right, Ra?
It depends on density,
You
sir.
can say it is similar to capacitance method.
Wait, Ra, by density for you, it will come. Wait.
So what were the three factors? R depends on nature, dimensions, and
I'll show you. Wait. Okay.
okay. So
This is called electrical resistance. It is scalar quantity. V by unit is called volt per ampere. Current is ampere and ohm. This is a symbol for 10 ohms. We'll do it like this one. 20 ohms like this one. Okay. So 1 ohm is 1 volt per 1 ampere is called 1 ohm. Dimensional formula this one. On what factors? Nature of the material, temperature and dimensions. Means what is the length, what is the area of cross section, those. Volume like this. Got it?
Yes.
Yes.
Done.
Done now.
Done.
Yes, sir.
Everybody done?
Done, sir.
Then we told drift velocity this one, you know. Hello, v equal to e plus at initially 0 acceleration to time only na.
Yes, sir.
So I am replacing, so et by this is nothing but what you call mobility na. Pd by e.
Yes, sir.
So we are writing v equal to like this. Then potential difference is applied. This is high, this is low. Current is flowing across the conductor. Right. So the length of the conductor is how much? L is nothing but D is equal to L. So V equal to ED. Electric field is V by L. Potential difference applied across the ends is V, and length of the conductor is L. So V equal to ED we applied. Here, what is electric field? V by L. Got it? Hello. Then we replace this electric field here. Then drift velocity is E tau by M into V by L. Got it? Hello. These are the relations later on they will ask none. Okay.
Got it.
What is J? J is I by N and VD is I by how much?
NE.
NEN.
Got it? Hello.
Yes,
Yes,
sir.
sir.
So J can be written as how much I by. What is I from this one? NEVD into this one, you know? I equal to NEA into VD only, you know? We'll substitute here. Got it? Hello.
Okay.
Substitute. Then cancel area cancel. What you got? NE into how much? VD. But what is VD?
E tau by M into V by
This
L.
one, you know? Hello.
Yes.
Yes, sir.
This one, you know? Got it, everybody?
Got it.
Then J is equal to some value we got. This is called sigma. We'll tell. Don't worry about it. Huh? Hello. We'll say that is called conductivity. Then which is called reciprocal of. Then E equal to how much? 0. This is the relation between electric field intensity and what do you call current density. First copy this page, everybody. Again, we'll discuss. Done, everybody, this page?
Yes, sir.
Done, sir.
Someone's gonna go back. Done.
So what is S then?
Both are same. Rho or S is called resistivity.
Okay.
S is called as specific
Resistance.
resistance, or we can call that as resistivity. Okay. Hello.
Yes.
What is Ohm's law, Natal?
V is equal to IR.
IR, na?
Yes.
So V can be written as ED, na?
Yes.
Right. Then, before going the design, we should know about the resistance and all, na? First, we will do this one, then it will become easy for you. Let us see. I told you now on what factors resistance. Resistance depends upon dimensions or not. It is
Yes.
proportional to length of the conductor, inversely proportional to area. What is the meaning? Suppose I have taken a conductor of small length, another conductor of very large length. Then same area, assume. Then this is shorter in length. Then number of free electrons available are some per unit volume same, but my electrons started from one point moving to the other. Then in the length is small, then what happens in the small length of the conductor, I can encounter very less number of electrons in the, or very less number of people in the collisions. That means I'll experience opposition very less in number because the length is small. Automatically number of persons I will meet in the phenomena or in the part of the process of what you call carrying a current, number of what you free electrons in the lattice available for me for the what you call collisions is less possibility. The why, what is the resistance, why it is called resistance means resistance is nothing but opposition for the flow of electrons only. That means electrons are could not able to move freely. That means some opposition is there. That is called resistance is there. So current cannot flow through that conductor very good way. So if you take a certain length of the conductor, length is small compared to another conductor of large length. Then here number of free electrons lattice remaining atoms are some n number are there. Then this electron will move zigzagly randomly with the help of electric field applied or potential difference moves, but it has a limited number of collisions. But the same, if you take a large length of the conductor, then it has to undergo collisions up to this much part, and the remaining so many people are also there. That means it will experience collisions with a larger number compared to what you call in a small conductor. Less number of people available. In a large length, more people are available, then I have to undergo collision with all these people. Probability of more collisions, more oppositions, more is the opposition. That's called more is the resistance. Got it, everybody? Hello. So length is large. What have done? Resistance, opposition is large. Understood, everybody?
Yes, sir.
All of you.
Got it, sir.
And how it depends on area of cross section. Simple. If the road is narrow, traffic is heavy. If the road is widened, traffic is less, easily can flow. No?
Yes, sir.
Yes, sir.
Similarly, if all the people are accommodated in small amount of space, definitely collisions are. If that area is large, for example, what do you call, let us say it like this one. I have taken 1 meter cube volume. I told you to prepare 2 cylinder cube wires. One you prepared with large length. Another you prepared, what do you call, let us say same length you will take. Then what happens here? Area is least na?
Yes, sir.
It is more crowded na?
Yes, more curious.
Here it is less crowded na? Because it is very wide. Got it? Then here the number of what you call people available in the participate, what do you call, like here population density is more, here population density is how much?
Yes.
Least. Then it is easy for the electron to flow this one than compared to this. That means more is the area of cross section, less is the possibility of collisions with the people. That's why more is the area of cross section is more, opposition is least. Then combining these two, R is proportional to L by A. Then R is equal to some constant into how much? L by A. That constant is nothing but called as what we call as a resistivity. It's called resistivity. It is constant for a given material. It does not depend on dimensions and all. It depends on only two factors: nature of the material and temperature. So rho is independent of the dimensions. It depends only on which one? Nature of the material and what do you call?
Temperature.
Temperature. So it is the resistance of unit area of cross section per unit length. That's why it is called specific resistance or resistivity. Got it? Hello.
Got
A is 1, L is 1. The resistance of the resistor is nothing but called its resistivity. That is called specific, means per unit area, per unit length of the conductor. Got it, everybody?
Yes.
Copy on this one. Resistance depends on nature of material, temperature. In additionally,
Dimensions.
but resistivity depends only on,
Nature and temperature.
but not on.
Dimensions.
The nature of the material means the wire used.
Copper, silver, lead, tin, like that one.
Okay.
Done, everybody?
Done.
Now come across this one. You learned what is R.
Rho L by.
Then D into add D is equal to L and I into R is rho L by A. Na?
Yes.
L will cancel. E equal to I by A into rho. E equal to 0. Na?
Yes.
So this and this are same only. Na?
Yes.
So this is V equal to IR. Which law?
Ohm's law.
Ohm's law.
This is also we can call as
Ohm's law.
Ohm's law.
Ohm's law. Because that is derived from which one? Ohm's law only, na? Alternative form. Got it?
Got it.
Copy, and if you're done, let me know.
Done, sir.
Done, everybody? Hello.
Done. Sir.
This is also done, na, everybody?
Yes, sir.
This will do later. Before that, you're done Ohm's law, na?
Done.
Hello.
So once can you show that page last page you wrote?
What are ohmic conductors? Which obey
Ohm's law.
Ohm's law. So V is proportional to R, I is proportional. Then if you draw a graph between I and V, straight line pass. What are non-ohmic? Which does not obey. simply you can say does not obey Ohm's law. Then the voltage versus I graph like a curve, or it will be like this one. These are which conductors?
Non-ohmic.
Non-ohmic conductor.
Non-ohmic conductors. All metals are ohmic conductors. Some semiconductors are there. And certain of the metals are what you call non-ohmic.
Done.
Got it, Nana?
Got it.
Hello.
Got it.
Let me show you. You see, this is that of a which person?
Ohmic. Non-ohmic.
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 For which one?
Non-ohmic.
Diode.
Diode.
And see this one? Gallium arsenide. Gallium arsenide is semiconductor material.
Non-ohmic.
See the curve? Got it?
Got it.
And they used a symbol. They tell what you call. They told one thing here. Observe here carefully. What is the slope will give here? Positive, no?
Yes.
Slope is?
Negative.
What is the slope will give?
Resistance.
I and B, na? Current and voltage na here.
Yes,
Slope.
one.
Slope is, if you take V and I,
R.
Then resistance.
Resistance.
then resistance. Got it?
Got it.
Yes.
Slope is positive. Slope is
Negative.
negative. One is a number. So R must be positive. That's why it's called negative resistance region. They told, no?
Yes.
This. Here it is called
Positive.
positive. Of course, non-linear, not a straight line. Got it?
Yes.
Yes.
What is meant by negative resistance region is nothing but no negative resistance. Got it?
Conductance.
Here V is increased, I is also increasing, not directly proportionate, something. Thereafter, a certain value potentially is increased. The current is not increasing. What do you call? Decreasing. Got it?
Got it.
Conventionally, we are saying negative resistance region. Got it?
Yes,
But
sir.
there is no question of negative resistance in practical life. Got it?
Okay. Sir, that
We can have the resistance 0 for superconductors, but no question of negative resistance. Okay?
okay.
Say silver. Least resistivity, silver. Next is copper. Next aluminum, tungsten, iron. These are, see, very huge values now. Resistivity, resistance. This is the smallest one. Means conductivity is very large. For which one?
Silver.
Electrical conductivity. Got it, Nana?
Got it.
Done, everybody? Understood, Nana? Hello.
Yes.
Done?
Done.
In this one, you have, hello, everybody.
Yes.
Have up to what you call drift velocity is there, no? Up to 13. Hello.
Okay.
Up to 13 you have. Hello.
Okay.
Yes.
Go through these. These are not.
Sir.
You try to solve these, Nana.
Okay, sir.
Chalo.